Hello all, welcome back to Aislyn Technologies YouTube channel. Today we're going to see about COVID-19 detection using transfer learning. First, I'll explain you the abstract. Here, COVID-19 pandemic has caused a strain on healthcare resource, especially in testing capacities. To address this, the study explores using computer vision based system, specifically convolution neural network, for detecting COVID-19. However, CNN models typically require large amount of training data to perform well. And since COVID-19 is a relatively new disease, such as dataset are not readily available. One solution proposed in the study is transfer learning, which involves pre-trained model on similar tasks to boost the performance of COVID-19 classifier. In this case, the study leverages a model trained on pneumonia dataset. Since pneumonia shares similar characteristic with COVID-19 in radiographs, by using transfer learning, the model's accuracy was significantly improved from 32 to 97%. Here, I will explain you the introduction. The introduction elaborates on a recent advancement in machine learning, particularly in deep learning, which uses neural network to perform tasks like image classification. These neural networks require vast amounts of data and computer resource, which are often unavailable for newer diseases like COVID-19. One effective solution is to use transfer learning, where a model trained on similar tasks is purposed for a new task with less data and faster training times. The study intends to use the approaches to create a COVID-19 detection model by transferring knowledge from models trained on pneumonia detection. Pneumonia has overlapping symptoms and radiographic patterns with COVID-19, making it an ideal candidate for transfer learning due to a small dataset available for COVID-19. The transfer learning approach is expected to help the model generalize better and improve performance. Here, a problem statement discusses about uh, it can transfer the different source domain like pneumonia and detection to improve the performance in classification in COVID-19 cases. And does it matter if the source domain for transfer learning is related to target domain, that is radiographic classification of a disease like pneumonia or else with other unrelated domains. So here our objective is to validate if the data transfer learning using a pneumonia dataset is practically approach to develop a COVID-19 classifier. Here the study aims to create a model capable of distinguishing between healthy patient with those with pneumonia and those with COVID-19. The outcome is highly relevant due to the recent COVID-19 outbreak, but the approach also holds broader implementation for the medical diagnostic, where limited data and expected labeled dataset pose challenges. Transfer learning could provide a way to train machine learning models with smaller dataset, reducing the dependency on extensive data collection effects. Since the labeling medical data often requires specialized knowledge, finding efficient way to train models with limited data is crucial for healthcare application. Now I will explain you the methodology what we have gone through. Here, machine learning based classification models can create using different algorithms and common approaches or supported the machine, naive Bayes and decision tree. These algorithms are in some cases nowadays being replaced by deep learning, which revolves around the neural network. The neural network models achieve better performance for computation problems where the data consists of images. This will use a convolution neural network since CNN has been shown to perform well on image classification tasks, like in this case with radiographs. Here, first what we will do is we will import our data set and we will work within reprocessing and data organization stuff. After that, what the features extracted will be given to the VG16 and some other algorithms. First, I will explain you the training code so that you have a clear understanding of this project. Yeah, here it is your training code. First, what we will do is this function is used. to load the image files and their corresponding class labels from this dictionary, and then our data set will be divided into train files and train targets. Here in this, our data set will be implemented here. The burn classes will give the uh, total how much number of images, whether our data set is as, and total number of training images and testing images will be given by this. And then here, the path to tensors, our image will be resized and then it will be normalized in the range of 0 to 1. Here, what we will do is, here we are expanding our dimension to 3D to 4D tensor, because while we are going to CNN, the CNN model will expect the input as 4D tensors only. So that we are expanding our 3D to 4D tensors here. Here, this function is used to plot the training history to visualize the accuracy and loss of the training and validation set over a box. That's what we will do here. And then this function is used to measure the time taken for training the entire model. Each epoch providing insight, it could be a training efficiency. First, we will create a CNN model. This is a simple CNN model. You can see this. First, we are given 32 layers, 64 layers, and 64 layers. And output is our target. It will become 3 here. After this, our model will be fitted here. Here you can see a confusion matrix of the simple CNN, and then we would like to add a dense net layer here, which has more in this. Yeah, here we have added dense net with more layers and parameters. It is useful additional convolution and pooling layer followed by the dense layer. Here we give 56 layers. The training and the evolution procedures are similar to the first model, which performance metrics and their computer will be plotted and further. And down, we have given a complex CNN model. Here you can see it has 16, 32, 64, and 128 and two up to 6 layers. It will capture more complex patterns from the image, and the model will mix an ensemble approach by combining more complex features extraction. And further, this model allows the same training evolution steps, including the plotting ROC curve and saving the model right weight here. And then accuracy will be showed here. And the reference score, the precision score of this model will be printed here. Here, our curve is to visualize the true and positive rates, and it will provide insights how well the model discriminative between the class. You can see in this hours curve. Yeah. Uh, Now I will show you a testing code. Here is our testing code. I'll run this. Here is our data set. I'll select any one of the images from this class. Pneumonia. Yeah, you can see the diseases part is segmented, it's a virtual image, and the predicted images is pneumonia. You can see this. I hope you see this. These are the results. Now I'll look for other image. You can see that also. You can see this was the virtual image, and this is segmented, and this is the result. And the predicted images is COVID. Yeah. Yeah, I hope you have good understanding about this project. If you have any doubt regarding this, you can leave a comment in comment section, and don't forget to like, share, and subscribe. Thank you.